Welcome everyone. I hope everybody is doing fine. It is my great pleasure to introduce our guest speaker for today, Dr. Pallav Sharda. Pallav is a medical professional by training. However, in 2001, he left his clinical career to pursue healthcare information technology industry. His work experience has centered on electronic health records, health exchange, and other software products dealing with health information. He is currently the global lead for healthcare products and strategy at Google Cloud. Before that, he served in various roles at GE Healthcare, Kaiser Permanente, United Health, and multiple other startups. He is also an author. His book on health IT entrepreneurship before disrupting healthcare was published in June 2016. I'll provide you the link for his book. He received his MBA from Northwestern University, Master's in Medical Informatics from Columbia University, and a Bachelor's of Medicine in Surgery from Delhi University. He's one of the few people that I know who has had a breadth of experience and breadth of education, I mean. So Pallav, welcome to our session. And we have participants, not just from my class, but there are other participants from San Jose State University, and I think also from Texas Tech University. All right. Pallav.
Thank you. And thanks for giving me the opportunity to be here. I hope this is interesting for you. As as we try to adjust with the new reality of working and together, I would like to give you all the opportunity to just stop me and ask questions through whatever normal way that you guys do in this class. And I'll try to answer them as we go through this. But I've kept some time towards the end of the presentation for some Q&A.
Yeah, and thank you. I should have pointed it out. Also, at the end of the presentation, we'll have a question and answer session. The way it will work is you ask the question on the chat. I'll repeat the question. So you can start posting the questions on the chat as they come. And at the end of the session, I can ask those questions. I can read out those questions and we can have a Q&A session.
Great. Thank you. All right. So what I thought I could do is, this class was about cloud as a paradigm shift. And I work in the corner of cloud technology, which has explicit connections with healthcare as an industry. I thought it'd be interesting for you to hear about my impressions and interactions with healthcare organizations and how they're thinking about using cloud technology. So everything that I talk about in this presentation is sort of public information. There's nothing confidential here, and whatever I'm saying here are my own views and don't necessarily represent Google Cloud's views. So with those caveats out of the way, I wanted to start with the origins of cloud. And again, this is all from the healthcare perspective, but it starts outside of healthcare. I wonder if people know this, but according to the last sort of report, there were 13 software products that had 1 billion plus active users. A couple of them, I think you've known intimately if you've used the Windows operating system. So Microsoft Windows, Microsoft Office, Facebook as a platform, and WhatsApp. But 9 of Google's products are actually with active 1 billion plus users. And the reason I point that out is because for companies that were going through this transformation, I mean, some of these products have taken 20, 25 years to reach 1 billion users. Some have taken 4 years. Companies that were creating these products had to think about how to scale and deploy these solutions as they were seeing user growth. And to understand the computation, the storage, networking capacity that it takes to create these massive products, that's what led to cloud being a paradigm shift in itself, because I work in an organization called Google Cloud, which actually is the underlying platform that powers the 9 Google products, but is also available to commercial companies to do digital transformation with. So that's the backdrop. And when we talk about cloud powering it all, and I only know this from a Google Cloud perspective, but I'm very sure that other public cloud companies, Microsoft, Amazon, IBM, they all have some versions of the same feature categories, functional categories. A large part of cloud computing, a large part of cloud as a paradigm is about computing. And storage, database, products, development tools, management tools, API lifecycle management products, they are all the core parts of cloud platform. Google is a little bit unique because it has its own sort of cloud native collaboration and productivity suite, which you guys might know as G Suite. And there's Google Maps, which is also built on cloud platform. So apart from those couple of unique aspects, you can think of Maps and G Suite as the first party app that Google has built using Google Cloud. The other half of cloud, which sometimes I talk about them as lower half of the cloud stack and sort of upper half of the cloud stack. So the lower half has the standard storage, networking, management, development, tooling aspects to it, where you do the basic data management and data pipelining and security aspects. But the top half of the cloud platform is all about leveraging that data capability and doing something with it. So the AI and analytics, the right-hand side of the box on the slide, that's what starts creating insights from the data. So it's a massive trend, and healthcare is not immune to it. I created this slide to give you a quick look. This is not meant to be read, word by word, but if you think about the lower and upper half sort of framework I gave you, at the bottom is the infrastructure as a service, and then as you move up, you get platforms and serverless products. But Google Cloud at present has 100+ products, and this list is already a year old. But there's a lot that goes into creating these reusable components that someone can use to create applications and do digital transformation using cloud products. So how is healthcare thinking about this? Well, first, healthcare is in a tremendous need for change. This is a graph from that plots the price changes from the last 20 years, and regrettably, healthcare services are getting way more expensive year after year, and everything else that things that we need are getting expensive, and things that we sort of want, cars, computers, TVs, they're getting cheaper. So this is unsustainable. And I think every insurance company or hospital system or government organization realizes this and is trying to use technology to bend the curve. And when it comes to healthcare, this digital transformation using cloud, it's not a one-stop, big bang transformation. It is a journey. And today, most of the market has created electronic health records and taken their paper forms to electronic versions. Although if you visit a doctor's clinic, you might still be handed a clipboard with paper on it, but rest assured that somebody uses that paper and inputs the information into electronic system, or it gets scanned into an electronic version. But bottom line being, our current status is that a lot of the paper workflows have moved to electronic systems, and as a result, there are data stores that are out there with foundational knowledge in them. So if you know, Kaiser Permanente is a big healthcare delivery system in California and other regions. They have a big claims warehouse. They have a big membership warehouse where they know who is a member of Kaiser Network and what claims they've given. And I personally worked on those two when I was at Kaiser Permanente, and they were massive endeavors. We moved from a standard Oracle Teradata type of setup to cloud. But when I left Kaiser, they were already thinking about how to create the tomorrow of the digital transformation, where you understand that you have certain valuable data stores, but how do you start exposing that data and sharing it through APIs? Creating different mobile experiences is also part of it. If you've used a Kaiser Permanente app or a United Health Group app, you know that you can look up nearby facilities or schedule an appointment in certain cases. But those are some of the pioneering organizations are already doing it, but that's kind of like what's coming as part of the transformation of healthcare. Now, that's the today and tomorrow. The future, and this is where cloud really starts shining as a capability, a platform, where two things are true, that AI is going to be a part of every workflow or every experience. And not everything will be done by the sponsoring organization. So if we're talking about Sutter or United Health Group or Kaiser Permanente, they are probably not going to build all the applications that are required, all the experiences that are required for a better care experience. They might create an asthma app, they might create an epilepsy app, but they're not going to create an experience and a digital version for every other health condition out there. So hence, they need to foster an ecosystem and be able to let others, third parties and partners innovate on their digital assets. So at a high level, that is the transformation journey. And if you keep that as a construct in your mind, that journey needs three things. And I'll hopefully start tying cloud capabilities to these three. The first thing is infrastructure. And I think you might have talked about this already, but if there's one thing that cloud is really good at, is providing you infrastructure as a utility. So that's the IaaS vision of you don't have to buy servers, you don't have to have physical data centers, you can just have a utility-based model. In healthcare, it's kind of special because it needs to be what I call healthcare grade infrastructure, because your data might be coming from a front desk, appointment system, or an ICU that is generating mission critical data about patients' health. So the kind of reliability and compliance and security needs are pretty heightened in healthcare. The second aspect is interoperability. And there are a lot of data silos in healthcare because every system used to have a proprietary sort of format and was unable to share data with other systems. So when you put data in the cloud, there are transformation capabilities that actually transform that data into a standards-based version, which becomes the canonical source of truth. And if using that normalized version of data, you can then do more things with it. And that is what the third point is about, is creating insights from the data, creating innovative applications, putting the data insights back into the workflow. Those are the things that cloud, again, gives you capabilities to do. So let me give you a couple more frameworks, and then I want to talk about some case studies that brings together this framework and gives you an example of how certain organizations have used cloud capabilities to do this kind of digital transformation. I'm not able to see the questions, so I'm going to assume that you'll stop me if there's a question in between.
Yeah, there are questions coming, but we'll wait for you to finish and then we'll read out the questions. There's some good questions.
Okay. Yeah, well, if it's about a particular slide, I'm happy to just stop and answer it. So I'll trust you to just let me know.
I think they're general questions.
All right. Okay. So all right. So this is how the big picture. So if you guys have ever seen an architecture diagram, this is like the most simplest architecture diagram possible, where if you start from the bottom, you can imagine that in healthcare, there's obviously a billing system, and ignore the acronyms that you see because these are industry-specific formats, and that those who are sort of insiders might recognize, but it has no bearing for the point I'm trying to make. So there might be a billing system, there might be an insurance system, there might be a hospital giving you a data, or a retail pharmacy like CVS, Walgreens, or your Fitbit might be generating data. So all that data at the bottom is coming at different times, has different formats to it, it has different values, but that sort of those ingestion data pipelines need to be translated into something that a machine can understand, and then finally stored as a common industry adopted standard. So let me explain the middle two boxes. So translation, it's a pretty straightforward concept, but translation from, let's say, a Word document to PDF is so commoditized that any sort of document writing software can do it. But in healthcare, taking an old standard like HL7 V2 and transforming it to a new modern standard, FHIR, which we call FHIR. I mean, you don't need to know what the details are, but FHIR is the latest industry adopted standard that has started being massively adopted in the last 5-10 years. But there needs to be a machine-driven capability to transform old legacy data into FHIR. And that's what a platform like Google Cloud or other clouds provides out of the box. So imagine if you are a patient and you're taking 6 medications, and 2 of them you've been taking for the last 20 years, and you were added 4 more this past year. So some of that data might be with your previous insurance company. Some data might be with CVS Walgreens that wrote the prescription. And as a result, these data feeds might actually have 10 medications in them because there's duplicates. So understanding the actual semantics of the medication brand name, the dosage, then deduplicating them and creating the canonical layer, which has the source of truth, which says Pallav Sharda has been on 6 medications for the past 20 years. That is what that blue box does. And I highlighted that because once you have that source of truth, then you can start leveraging the data, which is the topmost aspect, where you can build an application. I could have a medication adherence application that I use that has been built by Kaiser Permanente because they have all the data for me. You could send that data to a partner ecosystem. You could create reports on it, or you could just run AI prediction algorithms on top of it. But none of those value-added activities on data are possible in an efficient way unless you gather all the data streams from the bottom and then create a commonly understood format for it. So the value kind of increases as you go up the stack. And cloud has, like the 100+ products that a company like Google has, enable you to create those data pipelines at the bottom, do those transformations in the middle, and then be able to create the applications or the reports or AI algorithms on the top. So think of it as a toolkit that healthcare industry has adopted or is trying to adopt to create these modern digital transformations for the way care is delivered. All right, so just a side note here, although I explained the overall cloud stack here, this is a special instance of the cloud stack where I'm only talking about the artificial intelligence components of the cloud. And again, this is from a Google Cloud perspective. and most of the other cloud vendors have similar services. But if you go from the bottom, where if you are a sophisticated organization that has data engineers and a whole AI focused department, then what you're essentially using cloud for is to store the data, to create the networking and security, and probably use the hardware. Like Google Cloud has GPUs and TensorFlow processing units that are custom designed for machine learning. And you're at that low level product utilization where you're essentially using the Lego pieces and building your own solutions with it. But as you move up, you're getting more synthesized versions of AI capabilities. So the easiest to understand is the perception services, where if you've used Google Photos, you've seen Google Vision API at work. So if you type in just the keyword dog, you would see that all the photos with your pet kind of get pulled up. And how does Google Photo know that, in a particular photo, there's a dog? Is because it has been trained using Vision API on billions of consumer photos to understand what is an object that looks like a dog. So similarly, translation, speech to text, text to speech, natural language processing, these are like ready to go capabilities in terms of AI that are available if you adopt cloud technology. And perhaps an example would kind of like give you the context, but let's say I'm a multi-site hospital system, and I have a majority of Spanish-speaking population in one region, and my input sort of triage system is only in English. So to be able to translate my current capabilities into a new language, Google Cloud provides a translation API that automatically does that for you. And if you have Android or iOS phones, you probably can download Google Translate as an app and see it at work. It keeps getting more sophisticated. It can recognize who's speaking. It can recognize what language is being spoken. And it can actually, if you point the camera, it can actually translate on the fly. So things like that, that sophisticated capability previously would have to be solicited. The CIO from the organization would have to go out, evaluate vendors, see how to integrate them with the current systems. None of that is needed now, because if you're on the cloud platform, this capability comes sort of pre-integrated. All you have to do is leverage it as an API. And at the top of the AI stack is, if your organization has no machine learning or AI capabilities, then that's where the cloud ecosystem comes into play, where there are a number of service partners and technology partners in any public cloud that would be happy to look at your organizational mission and help you leverage the cloud capabilities to create the AI embedding in your products. So there's various levels of AI capabilities that can be leveraged depending on what kind of organization you are. All right, so that was all talking about how important cloud is, what does it bring to the table, what can it do for healthcare transformation. I think in my mind, looking at case studies and examples really solidifies all this. So I picked a few that are worth highlighting. So Broad Institute, for those who don't know, is a MIT Harvard affiliate that basically does genetic tests. And I think they do like a petabyte a month, something like that. Some inordinate amount of data flows through their systems. And their queries were taking 8 hours to complete. And when they moved to the cloud by moving their data to the cloud and using the compute cycles available in the cloud as a service, their queries were completing in 15 minutes. So this is an example of a research institute that would have had to build their data centers for peak utilization, and then have them be underutilized most of the time. Whereas with cloud, they only pay for that sort of burst of computing and then fall back to like whatever normal level they have. So that's one sort of research-oriented example. This other example is of a company that makes a medical image viewer. So when you go get your X-ray or MRI, the software that takes that image from the machine and displays it at a computer screen for the radiologist to look at, that's called imaging viewer software. And usually these softwares sort of used to come pre-packaged with the imaging machines like from Siemens or GE, but increasingly the images are now stored as in a specific healthcare format on the cloud. And once the images are in the cloud, you need to be able to view them. So Ambra makes the infrastructure for storing and viewing medical images, but they were running into a problem where they weren't able to de-identify the X-ray or MRI images, because sometimes you would have the patient name written at the corner of the image by the software, the machine software itself. Sometimes there are edge cases where somebody was wearing a necklace that had the patient name on it, and that also got burnt into the pixels of the image. So by using the vision API capabilities in the Google Cloud, there is a de-identification service for medical images that my team has built, which takes the medical images and anonymizes them so that they can be used for research or can be shared. So if you think about the Ambra engineering group, they would have had to figure out how to understand patient identifiable data themselves, then figure out how to anonymize, mask it. And that was the old traditional view of application development. But since they were on Google platform or cloud platform, they had the cloud capability for image de-identification that they leveraged and were quickly able to create a feature for their product set. So that's like the vendor view of application evolution using cloud capabilities. Second last example, case study, is from Brazil. So Portal Telemedicina is a telemedicine company in Brazil, and they built their entire platform using cloud technology. So not just storing the image, they were also analyzing the images and the videos using cloud technology, and they were able to get the whole system deployment time down from 2 weeks to 30 minutes because most of the functionality happened in cloud. So it's almost like a telemedicine care delivery example in healthcare that was enhanced because of cloud technology. All right, last. So Rush University, it's a Chicago-based medical center, kind of like Stanford Healthcare. And they basically had a number of electronic health records, a number of sort of systems of record that had multiple pieces of information for their patients. And they were able to use the data analytics capability of cloud to create a data lake, put the data in, and be able to analyze it to create a mobile app called MyRush for their patients. And it has seen amazing utilization. And now they're thinking, I had spoken to the CIO last year, and they were thinking of putting in features like with consent, letting the patient tell them that they're on their way to the Rush University Medical Center and be able to receive them with like the right care navigator or the right staff in place. So patient care experience being digitized using cloud technology. That's the example here. And that's it. So that was my pitch. Would love to take questions and talk to you guys about it.
All right. Thank you so much, Pallav.
Sure.
That was an excellent presentation. I have a bunch of questions already. The first question,
Okay.
when you're talking about health data and you're talking about cloud, a lot of people are kind of like curious about security. So the question is,
Sure.
what struggles with security since a lot of sensitive, highly sensitive information is involved?
Yeah. It reminds me of like a Houdini quote of those who believe no proof is required and those who don't, none will suffice. But security is exceeded in cloud platforms. And I'm not just talking about Google. I think all cloud vendors are extremely aware of privacy and security being the top customer concern. So how do we ensure it? Couple of things. One is we conform and apply for industry certification. So if you're from healthcare, there's HIPAA certification, high trust. It's kind of like ISO. There's government certifications for security that are consistently being exceeded. So there's that. Being certified is one answer. The other is, these are all enterprise operations. So there's security is built in from the ground up. I mean, I don't know if this is common knowledge, but Google actually builds its own servers. And each one of Google's servers has a physical security chip that's installed in it. So it goes from like the hardware BIOS level to the data center that it's being installed in. That's secured with physical sort of security and access controls, to software threats being identified and being squashed. And sometimes when my enterprise customers ask me about security, I ask them to think about or give me a rough number of how many security engineers they have on their team. And it's usually 5, 10, 15. Well, Google has 700 plus. So I think cloud used to be a security concern when it started 10 years ago, but it has almost flipped on its head because there is an industry acknowledgement that you cannot do security as good as the public cloud vendors because they are concentrated on it. So I think that's a very old notion that just comes up because people are not sort of aware of what has happened in the last 5, 10 years.
Awesome, thank you. The next question is about application of the cloud, and Internet of Things is one of the prime applications, and healthcare also is one of the big customers or big potential for this. So the question is, are there healthcare facilities working towards having at-home devices or wearable devices that can send information directly to the healthcare physicians to give potential alerts and all?
Absolutely. I'd be hard pressed to think of a major organization that's not thinking about it. And actually the concept of, it used to be telemedicine conventionally, now it's more virtual care, because with COVID crisis, what we've seen is all the sort of commodity healthcare interactions, like, going in after your, for like a mental health checkup or, pre-pregnancy checkups where you're essentially not really touching the patient, but just meeting them. Those have all started moving online. Dermatology is a good example. A lot of the times the interactions are doable with a photograph. And there's an increasing move towards taking those service lines that are amicable to being virtually delivered and starting to figure out how to deliver them virtually. Obviously, something like surgery or something like oncology, chemotherapy or something like you have to be there in person. But if you're feeling nauseous after the chemotherapy and there's something you want to get done, that should be a virtual call with your physician and a prescription written that shows up at the nearby pharmacy, and you never have to set foot in the facility. So you would see, well, I'm seeing it, but if you've not noticed, I think if you start paying attention, you'd see a lot of companies offering telemedicine benefits as a part of their employer health benefit packages. What else?
So these are good questions. Thank you. The next question is about ethics, and the point is that with all these cloud and processing and everything becomes so fast, decision making is becoming faster. Is it ethical to base decisions on technology? I guess the question is about human intervention versus technology reading the.
Yeah, I think so. Definitely a valid sort of area to think about. And I love the question because I think it's not just a philosophical question for me. I actually can give you a couple of examples of how products are being created to tackle that question of ethics. So I think the concern at the heart of ethics in AI or cloud computing is because it seems like a black box at some level. So why did a particular prediction happen? What led it to be predicted that way is not clear. So at least in, again, my experiences of Google Cloud, I'm sure other cloud vendors are also doing something about it. But Google Cloud has a AI product called AI explainability, where the model that you create will start telling you why it reached a particular conclusion, what data points or what particular attributes skewed it towards that. So I think people are being much more aware of the ethical aspects of analytics and AI, and we're starting to open up the black box. We're starting to look much more closely at data that goes in, because if the data is predominantly of a particular subtype, if it's just, white Caucasian population, then you're not going to have a widely generalizable prediction that comes out of it. So looking at data and knowing the origins of it, having products like AI explainability, those are the ways we're trying to tackle the ethics issue. I do think that fundamentally we've reached a spot that this is going to be a continuous, ongoing discussion. To be kind of double clicking into it, we'd have to pick up a context of like in what scenario are we talking about ethics? Like, is it an ICU monitor that's giving out an alarm or suppressing an alarm, or is it is it something else? So, but valid area. I think software engineering leaders are thinking about it, and it's going to evolve.
Awesome. Next question is about the FHIR system that you talked about. What is the estimated cost to assimilate and adopt the new FHIR system for a typical business? And how long is the timeline to completely and effectively transfer to the new system?
So cost. Look, I think the cost is less than what you would have to do in a traditional setting. I struggle because is it a 400-bed hospital, or is it like a multi-hospital chain with 16,000 physicians? It depends, but the foundation of cloud is the pay-as-you-go sort of utility-based model. So I've never seen, and this goes again for all cloud vendors, there's this notion of if you're not using it, we're not going to charge you. So the cost has to be quite closely reflecting what it actually, what actually is the cost of goods sold. So I don't have a figure in mind for what it would cost because it just really depends on, are we talking about petabytes of data? What kind of storage are we putting them in? Generally speaking, the more sophisticated things you do, like if you're doing natural language processing, it would cost you some higher fractions of a cent to run a page through medical natural language processing. If you're just storing, it'll be some ridiculously cheap amount of storage because we're not transforming the data, we're not understanding it in any way. So the cost is going to increase as you go up the stack, but it's usually fractions of a cent per unit. So,
All right, thank you. I'm going to skip one question because I think you've already answered that question. It's about how trustworthy is the cloud. So the next question is about standardization of the data and how difficult do you think cleaning and getting the data in the same format would be, and would that be a barrier or not?
Oh, it's amazingly difficult. I would say that that's the crux of the problem right there. So you might, I only know about healthcare, but I have a sort of sense that most industries are in the same situation where you have standards, but they get abused. You have, specifications, but they're not followed. So a lot of what, we all talk about artificial intelligence and predictions and whatnot, but in the end, all of that runs on a clean, semantically normalized data set. And if you don't have the data, then predictions aren't worth anything. So I think that is where the game lies. It's easy, like the endpoint, the ingestion points are probably a little bit more easier because it's going to be a FTP file drop, or it's going to be some PDF or CSV file or HL7 format, whatever. Systems have been generating data for a while. It's just that it's messy data. And clearing that mess is not about, looking up a specification and sort of mapping a field to another field. That's like the human operator way of doing things. If you've heard Google's pitch, at least we're an AI first company. So I feel like this is the recursive nature of AI, that before you actually leverage the data, the actual act of transforming the data can also use AI in it. So for example, if you're getting an HL7 message that used to have age in segment 3, and all of a sudden it has stopped appearing in segment 3 because the sending system now stuffs it in segment 5. You don't need a human to kind of now go check which field it is in and then map it to field, segment 5 instead of segment 3. If you think about it, age is a well-recognized pattern. It's going to be double digits most often, and it's going to have to be numbers only. So looking at that pattern and auto-recognizing that the message format has shifted to segment 5 is something that AI can do. And that's what really excites me, because the more we get these data pipelines made, the more we can apply AI to the pipelines themselves. And that's what really you would probably see in the next few years, a turning point where essentially you throw whatever you want at this data pipeline and it starts recognizing the value out of it. And it has already happened from a photos perspective. Like if you use like filters in a photo app or like Snapchat or someplace, that camera, that processing knows where the eyes are or where the nose is, where mouth is. It is very, very good at it. So that same sort of iterative sort of learning will happen on data pipelines, and it'll just make them better and better. So, and I think that's where cloud starts to shine, because it actually just takes your messy data pipelines and gives you like a clear foundation to build on.
Fantastic. Next question is, what type of accuracy standards would these AI products, such as X-ray imaging, need to meet in order to be widely accepted in the healthcare industry?
What kind of accuracy standards?
I think they're talking about.
Look, I mean, I never.
Right.
I think I understand the crux of the question. I think when does it start getting adopted in clinical practice? I think when it starts being useful. I think it's wrong to have this notion that AI is going to somehow, start diagnosing stuff or replace the physician, or I don't think in healthcare there's going to be a closed loop AI. By that I mean the machine generates some data, the cloud AI or AI looks at it, and then a new medication is prescribed or a new infusion is administered without a human being in the loop or like signing off on it. There's just too many nuances at present, and plus the way the regulatory structure is looped around healthcare. I think AI needs to be useful enough. For example, if the artificial intelligence can figure out that there is a abnormal mass in this chest X-ray, I don't think we require it to diagnose what that mass is. What we need is to point it to the radiologist to say, look here. And that's when it starts getting adopted. A great example for this, which is already happening, is if you know about mammograms, they're essentially the two-dimensional X-rays of a breast, and they used to be 4 images because it was top, bottom, side, left and right images. But when digital, 3D mammograms started happening, it started being in hundreds of images per breast. And if you're a radiologist, it's not like you have 20 times the amount of minutes given to you to now read a 3D mammogram. You need to be told that look at slices number 26 through 36, because that's where something abnormal is. And that kind of capability is perfect for AI, and it's perfect for adoption. And that's what's happening, because it's assisting the primary decision maker. And if that's the way we implement it, then the adoption is already there. Like it's happening. On the other hand, if we're thinking about like some online chatbot that figures out, looking at your picture, what kind of antibiotic you need, I don't think that's that adoption is going to take decades. So it just depends on the context.
Thank you. So there are actually a couple of questions with regards to the costs. So I'm going to combine them.
Sure.
The implementation of the cloud technology in healthcare increase the cost or reduce the cost of the patient care? And
Good.
a follow-up question is, how do you ensure elder population keeps up with the virtual appointment or examination? I mean, are they...
Okay, well, let me answer the first one, and maybe you can repeat the next one after that. So the increase or decrease the cost of patient care. Look, okay, from a CIO, CFO perspective, there is a big budget to do capital expenditures, open up a new hospital wing or order a bunch of servers. Usually CapEx is way more than OpEx. And what cloud has done is actually taken all your IT infrastructure, capital expenditure, and now converted it into operational expenditure. And sometimes finance is not set up like that. So what hospitals struggle with is to pay like $10,000 for cloud storage instead of $5 million at the beginning of the year for buying a bunch of servers. I mean, they'd rather do the latter. And from that perspective, if OpEx cannot take the hit and is being asked to take the hit, then I think you would see the margins go down in a hospital. But if you really do finances right, then you saved, $4.99 million, by converting your capital expenditure into something that's pay as you go. So it just depends. If it's a progressive organization that has figured out that they're going to do things in the cloud paradigm, then they're going to be able to pass those cost savings down to the patient, and you would see probably less cost of care being less. But if they're not, then this is just being added to their OpEx bottom line, and you're probably going to see an uptick. So it's just a very fluid situation.
Thank you. The next question was, how do you ensure elder population keep up with the technology, virtual appointments, examinations, and web appointments?
I honestly think that there's a little bit of a fallacy that, we think elder population is not good with technology or doesn't use them. I think, again, what is the utility? Because I think we all know grandparents who have learned how to use iPads or do video calls to keep in touch. So at Kaiser Permanente, the patient portal, there was like 80% utilization from patients 65 plus. People respond to technology if it's providing some inherent value. At Kaiser, the patient portal actually was the way we delivered test results to our members. And if you were a senior and you just got an important lab result, a lab test done, wouldn't you want to know the result? And if you want to know the result, you can know it faster, more easier if you log into your portal. And that's what they did. And once they did, then they started messaging their doctors because the email feature was right there. So I feel the adoption is very high if the value is there. I don't think that you would find, for example, the other end is some of these pillbox apps like medication adherence apps that are, so many on iOS and Android platforms. I don't think there is a senior out there who's testing and downloading medication apps just to get reminders for when to take them. There may be some, but I don't think that is, because they're probably looking at their care provider or some peer who's done or like telephone reminders or something like that, which is more conventional. So it just depends on what the use case is. I actually think the adoption is actually pretty significant for after like hip replacement or other things that are major surgeries. Patients usually get the habit of working with text messages or working with a chatbot to understand what's going on and ask questions. So I've seen the other side actually.
Awesome. So, you're a trained medical professional and you changed your careers, and there's a question, related to how can someone from a different area like management, finance, marketing assess and understand the impact and trade-off of new technological application outside of their expertise. It's not exactly related, but kind of like, you moved away from your area of expertise into, to get into more technological area. So how do you recognize this kind of a thing?
Sorry, so the question is about how do you recognize opportunities outside of your normal, like the usual conventional field?
Yeah.
I say, maybe everybody has their own journey, but I feel like technology is a common thread, no matter, like if you're in travel, gaming, healthcare, finance, tech is like a common underpinning. So as long as you keep your eyes open for what's happening, like for example, it's like 2007, like end somewhere there when iPhone came out, where every VC that I was talking to knew that mobile was the next wave. We know AI is the wave now. There's going to be other waves that are fundamentally disruptive to every industry, whether you're in MIS or healthcare or wherever. I think you have to. I actually admire people who keep track of problems, not solutions. So don't look at like AI as the solution kit. I think continue to find the problems that are in front of you in the field of your that you've chosen, and you will find that then that leads you to the right solution. Often enough, we have a very solution driven approach. Like, I have this solution, what problem can I solve in healthcare? And that invariably is the wrong way to do it. I happened to start with a medical career first, so healthcare became part of my fabric. But if I was somewhere else, I would still probably be drawn to technology and would try to solve the problems of my field with technology.
Thank you so much. I know time is a constraint, and you have to go. One last question: any advice for students pursuing career in Silicon Valley and in the area of information systems?
I think never miss a chance to cross-pollinate with other fields. Like if you have School of Engineering, School of Design, at this point, I think the future fields are a mix of the current fields. And just like data science came from nowhere and became a major field, I think wherever you are, find opportunities to cross collaborate with other disciplines, and you will find that you're probably a pioneer in whatever is the next wave. So don't pigeonhole yourself.
All right, thank you so much. We really appreciate you coming and spending time with us. It was a great presentation.
Thank you, and thank you everybody. Like great questions. I enjoyed it.
Thank you so much.
All right, have a great rest of the class. Bye.
Take care. Bye. All right, guys, I'm going to see you back in the regular session. I'm going to close this meeting and I'm going to restart the other meeting that we have.